waveform is the shape and form of a signal, such as a wave moving in a physical medium or an abstract representation. In many cases, the medium in which the wave is being propagated does not permit a direct visual image of the form. In these cases, the term waveform refers to the shape of a graph of the varying quantity against time or distance. An instrument called an oscilloscope can be used to pictorially represent a wave as a repeating image on a screen. To be more specific, a waveform is an set graph that represents an audio signal or recording which shows the changes in amplitude over a certain period of time. The amplitude of the signal is measured on the y-axis, as time is measured below on the x-axis. Most programs show waveforms to give the user a visual aid of what has been recorded by imagery. If the waveform is low, the recording was most likely soft. If the waveform is large and covering most of the image, the recording may have been recorded with the levels high. Waveforms can vary. They may be small when there is just a vocalist singing, but may become much larger when the drums and guitar come in. Examples of waveforms. Common periodic waveforms include sine wave, sin. The amplitude of the waveform follows a trigonometric sine function with respect to time. Square wave, saw minus saw. This waveform is commonly used to represent digital information. A square wave of constant period contains odd harmonics that decrease at -6 decibels, octave. Triangle wave, 2, floor, 2. It contains odd harmonics that decrease at -12 decibels, octave. Sawtooth wave, 2, -1. This looks like the teeth of a saw. Found often in time bases for display scanning. It is used as the starting point for subtractive synthesis. As a sawtooth wave of constant period contains odd uneven harmonics that decrease at -6 decibels, octave. Other waveforms are often called composite waveforms and can often be described as a combination of a number of sinusoidal waves or other basis functions added together. The Fourier series describes the decomposition of periodic waveforms, such that any periodic waveform can be formed by the sum of a set of fundamental and harmonic components. Finite energy non-periodic waveforms can be analyzed into sinusoids by the Fourier transform.